Today we're going to be learning about graphing sines. So graphing sines, we're going to start off with this problem as our base problem. As you can see, we have an amplitude, period, phase shift, and shift. We have no phase shift nor shift because the phase shift comes after our variable. There's nothing after variable, so we assume it's nothing. Our shift is any number before the sign, anything added to the function. There's nothing there, so there is no shift. Our amplitude is any number right in front of our function. There's nothing there, so we assume it's 1. Our period would be any number in front of our variable. Since there's nothing there, we assume it's 2 pi. Since assuming our amplitude is 1 and our period is 2 pi, we come down to our graph and graph accordingly. Now let's try something harder. Y equals 4 plus 2 sine, parenthesis, pi over 2x plus pi over 2, parenthesis. So as you can see, we have our basic graph drawn out. As you can see from our equation, our amplitude is 2. Our period, we're going to pull this out and divide by 2 pi. Our period will become 1. Our phase shift is going to be the number right there divided by 2 pi, which is going to create it 1 again. And our shift is in front of our function, being 4. And now you graph accordingly. So we come over -1 for our phase shift and up 4 for our shift. After doing so, you start at our origin, come over 1 and up 2, and you graph accordingly. And that's how you graph a sine function.
Our next graph will be graphing tangent x. For tangent x, the average period is pi. It's shown here. For pi, there's 2 sections. So we divide pi by 2, which is leaving us negative pi over 2 and pi over 2. And for every time we pass the x-axis, it creates a 0. For these zeros, we create them to asymptotes, as shown here. And that's the average graph for tangent, which is a cubic-like structure. Now, to graph this more complicated problem, we have to see if there's an amplitude, period, phase shift, or shift. There is no amplitude because it's a tangent graph, so we don't need to worry about it. But for a period, since there's no number in front of the variable x, we don't need to pull it out. But there's a number in front of the argument, so that's the number we need to divide pi by, which is the average period for tangent. So pi divided by pi equals 1. Now, since it's 2 sections, we have to divide that 1 by 2, which gives us 1/2 for each section. So it's going to be negative 1/2 and positive 1/2. So these are where our zeros are supposed to be at. But first we need to look if there's a phase shift or shift. If there's a phase shift, well, yes there is. So for the phase shift, we have to move right 2. So we move our origin over 2. So that's 1 and 2, which will end up at 2. And since we moved the origin, now we have to move the zeros as well, which are also the vertical asymptotes. So that's 1, 2, which leaves us at 3 over 2. And for 1/2, it's 1, 2, which leaves us at 5 over 2. And now let's just mark up the asymptotes. And since there's also a shift, it's a shift to 1 since it's in front of the tangent argument. So we have to shift up 1 unit. Now let's draw a horizontal like asymptote as a guide, not an asymptote itself. And so this is where our original x-axis will be now. So to graph it, we want to start from the bottom and make a cuboid-like structure like seen here. And since there's no flip or any other type of push or shift, we can just graph it as it is now. And that's how you do a tangent graph. For our last graph, we're graphing y equals cosecant x, which also means 1 over sine x. Well, let's start off with graphing a sine x. Well, for sine x graph, we've already went over it, so it's shown here. Let's skip ahead. Every time you hit the x-axis, we're going to make a vertical asymptote, which are these separated lines here. Make it short, all we have to do is bounce off the original sine axis. Alright, let's move forward. This is the problem we were given, which is y equals 2 cosecant parentheses pi x plus 2 pi parentheses, which also just means 1 over 2 sine pi parentheses x plus 2 pi. Parentheses. We pulled out the pi already because it was necessary. So the amplitude is 2. The period technically is 2 pi, but since we pull out a pi, it's 2 pi divided by pi, which equals 2. Since there's 4 sections, we divide by 4, so every section is 1/2. And there is a phase shift, which is to the left 2. Alright. Originally, sine starts at the origin, which is 0, 0. So we have a phase shift 2 to the left. Let's just move that to the left right now. So 1, 2. And the average, and our amplitude is 2. So its points are here, passing through the x-axis here, down to, and then ending at the origin. Now every time we hit the x-axis, we have to make vertical asymptotes. And then again at the y-axis. And now let's graph it originally like a regular sine, like I said to do. Just like this. Now all we have to do is bounce off that sine graph. So we're going to use blue, and all we have to do is bounce off. And bounce off. And that's how you graph a cosecant graph.